So you know how to take the area of a triangle, right? It's 1/2 times the base times the height. But what if you couldn't do that? What if your professor wanted you to find the area in terms of the determinant? And we can do that. If you're given 3 points, the area is positive negative 1/2 times the determinant of those 3 points in this specific orientation. Now we can cover the proof, but that's not really why I want to make this video. But if you're curious, here it is right here in the flesh. If you have a triangle with 3 vertices, you can use trapezoids to find the area of that triangle. Where you have 3 trapezoids, where the T1, T2 are your upper trapezoid, and you're subtracting the 3rd trapezoid, which includes the void underneath the triangle in the graph given. And yeah, you'll see here's T1 plus T2 minus T3, which is equivalent to this monstrosity of an expression. And yeah, that's pretty much the proof for finding the area of a triangle. But it's very likely that this part of the properties of determinants will not be covered, and instead you'll be given a numerical example. And whether or not you can do that is dependent on whether or not you remember the formula. So let's begin with a numerical instance. So if you're given these 3 points, how do you find the area of a triangle given these vertices? Well, let's incorporate the equation. So it's 1/2 times the determinant of x1, y1, and 1, which is 1, 1, 1. And the second row is x2, y2, and 1, which is 2, 2, 1. And the third row would be 4, 3, 1. Let me just fix that up right here. And we know, well, you can just plug this into your calculator, but it turns out that the area of this triangle ends up being negative 1/2. Don't worry if the area is negative, it is possible. It just means that in conclusion, the area of this triangle is a half square unit. Now, we got that out of the way. And let's see here. What happens, right, if you give the same 3 points, but they end up being collinear? What does that look like? Well, you're given an XY graph, and you're given this. You're given 3 points that are on the same line. What happens to the area when you use the given equation that we just went over? In other words, if 3 points on the same line, what is its area? And believe it or not, you don't have to use the formula for this. Because what's the area of a line? It turns out that the area is just simply 0 square units. And that's pretty much what you need to know on the side. Anyways, that's how you find the area of a triangle in terms of determinants. And thank you for watching.